Okay, in the last video, we just did some resolving single forces in two different directions and did a few examples as indicated. Basically, we were splitting to a singular force into two perpendicular directions. It's quite important we've got that. So if you haven't seen that video and you're new to this, you really do need to see that or something similar so that you know what resolving is about. I wanted to do a more complex example here. Here we've got four forces involved, and the idea is to find the overall resultant force, if you like, and split into two different directions. So let's just talk about resolve horizontal direction, x direction. So, and we're going to do the same thing perpendicular to find the overall force in each direction. And we've got four forces going on here. So let's do the x direction first. Okay, so we need to actually look at all four forces to work out the overall force vertically and horizontally, x direction and y direction. Okay, so let's look at the 6 Newton force first. Might change the colour, so we've got a different colour there. The 6 Newton force first. Right, well that is already horizontal, so we don't need to resolve that in two different directions. That's already 6. Okay, there is no, that's the component horizontally. It's already going horizontally. Then let's look at the 9 Newton force. Well, that has got a component horizontally there. And if you saw my video last time, we don't really need to draw the vector triangle here. We shouldn't need to. It's just next to the marked angle 30 degrees here. So that's 9 cos 30. So that's plus 9 cos 30 because it's going in the positive direction. Okay, then we've got the 8 Newton force. That is actually going in the other direction, but let's find the component of it there. The component horizontally will be here, but notice it's away from this marked angle here. So that means it will be sine. If I was to draw my vector triangle, the force is up there, but I just trying to get away from that approach and just recognize which component you're after. In this case, because we kind of got a gap here, it's away from the marked angle, so that is sine. So that's minus 8 sine 25. Right, there is another force, this one, but that has no horizontal component. It's going only vertically, so it has no horizontal component. So that's not going to come into it at all. Okay, so that's not going to come into it at all, and that is it for the actual resolving horizontally. Okay, I might now work that out on my calculator just for the hell of it. Sometimes it will actually come in the form of the equation as you see in the next video. But let's work it out. Okay, to 3 significant figures, that's coming to 10.4 newtons. So the overall combined horizontal effect of this system of four forces is a horizontal of 10.4 newtons. Okay, let's now go vertically. Okay, let's look at all four forces and the vertical components of. Let's look at the 9 Newton force first. Oh no, let's just talk about the 6 Newton force first. That's got no vertical component, so it's not going to come into our vertical equation. So that's no vertical component because it's only going horizontally. Okay, so that's got no vertical component. So that's not going to come into it. So now on to the 9 Newton force. The vertical component here is here. We've got the marked angle that we're given here is 30 degrees. We're kind of away from that. There's space here. So that would have to be 9 sine 30. And it's positive because it's going upwards. 9 sine 30. And then so that's that one, and then we've got the look at the 8 Newton force. That's got a component going upwards as well, but this time we're kind of next to the angle mark 25, so it's adjacent to it, so that's 8 cos 25. And again, it's positive, so it's plus 8 cos 25. Okay. Downwards, well, this again is not, this is going directly downwards. It's going directly downwards, so that's going to be minus 4. Okay, there's no triangle going on there, no components, no angle, it's going bang on downwards, so that's minus 4. Notice that there's a useful check after you've done this. If you've got cos on your horizontal, so 9 cos 30, it would have to necessarily be the opposite one, so 9 sine 30 on the vertical. And likewise here, we've got sine 25 there, so we've got cos 25 there. And that's a useful kind of thing to check out for. It doesn't 100% guarantee you're right, because you might have gone completely wrong, but it's definitely wrong if you've got the same ratio on horizontal and vertical, because one of them has to be cos and the other one has to be sine for any individual force. Okay, so let's quickly work that out. Okay, so that comes to 7.75 newtons. So this overall is our resultant force, and we could, if we wanted to, actually express all this as a single resultant force. So the resultant force of that system of 4 forces would be the force that's going 10.4 across this way, and 7.75 this way. Okay, or we could write it as a vector even, couldn't we? We could say the resultant force is 10.4, approximately 7.75. Not often asked for the resultant of a system of forces, but that's one way of that we could do it if we wanted to. So this system here could be replaced by a single force called the resultant by looking at the horizontal components of the system of forces combined and the vertical component of the system of forces combined. That process is called resolving forces. So that's our second video on resolving. What it might be useful now is for you to have a go at these 4, pause the tape, and I will quickly go over the answers to those as well. Okay, so let's look at A, the horizontal. Notice I'm using this notation here to mean resolve horizontally. The horizontal of the 8 Newton force is 8 cos 60, because we're next to that, minus 6. Okay, and the vertical is 8, just 8 sine 60, because there is no vertical component of that. So, and it's away from the angle, so it's 8 sine 60. So the answer to this one, cos 60 is half, so that's going to be equal to minus 2. And 8 sine 60 is the square root of 3 over 2, so that's 4 the square root of 3 exact. So we're not asked for the resultant, but if we were we can see the combined would be minus 2 for the square root of 3 if we wanted to write the resultant as a vector. But we've got our 2 components, resolve vertically and horizontally, and there we have it. Okay, for B, we've got the horizontal, we've just got these 2 in our equation because this one's vertical, and they're both cos because this one's next to the marked angle and this one is also next to the marked angle. So that comes to 6 cos 40 plus 6 plus 5 cos 45. Okay, let's work that out quickly on the calculator. So that comes to 8.13 newtons. Okay, resolving vertically, we've got 3 forces in this now, because we've got the 10 Newton force going upwards. Now, they were both cos now, so they'll both be sine, but it's worth looking at it just to check. the component here, we've kind of got a load of space there in between, so that component is 6 sine 40. So that 6 sine 40 going upwards, so that's positive. But we've got going downwards here 5 sine 45. And that is it. So that comes to 11.06 or 11.1 to three significant figures. So again, the resultant would be approximately 8.13 and 11.1. And then finally, C, this is a more algebraic thing. We'll see a lot of this kind of thing where we're setting up equations, as you'll see in future cases. So we, in this case, again, horizontally, we've got three forces in there. Q is already vertical, is already horizontal, so that just comes to that. Then we've got this component here will be P cos alpha, because it's next to the angle I've marked there. But this one here will be R sine alpha, sine beta, sorry, because we've got a load of space there, so we're away from the angle where it's marked, sine beta. Okay, and that's just the answer because we don't know what the actual numbers are. So that's what the sum of the horizontal components are. The sum of the vertical components. Notice Q doesn't have a vertical component. So the P, we've got P sine alpha going upwards, and we've got P cos beta because it's next to the angle there going downwards. Not P, R cos beta going downwards. Okay, and those are the horizontal and vertical components combined. Okay, that's it. And in the next video, we're going to be using this much more with forces in equilibrium. So if they're in equilibrium, the forces are equal to 0, which, being honest, is a far more common use of the techniques that we've done in the past two videos. It's where we're dealing with equilibrium. Occasionally, we'll see later on where we're applying F equals ma if there is a resultant force as well. Okay, so that's it till the next video when we'll look at cases in equilibrium.